Right. Can everyone see this?
Yep.
Yeah, great. Awesome. And I guess it's about time to get started. All right. Hello, everybody. My name is Guillermo Valle. Welcome to our third workshop of the semester. Today, we're going to be going over Git, so I'm pretty excited. So let's get started. So this is what we're going to cover in this workshop. So very first, we're going to cover version control systems and what they are. It's important to introduce Git in the context of version control because Git aims to be a solution for this problem. Following version control systems, we're going to talk about Git and what Git actually does and what it is. And then we're going to get you guys started on GitHub, get you set up with a GitHub account. Following that, we're going to go into a demo where you're going to get a little bit of a taste for the Git workflow. And then I'm going to open up the floor for questions. Right. So next slide. All right. So version control. So what is version control? So version control is the task of keeping a software system consisting of many versions and configurations well organized. What does this exactly mean? We want to be able to keep track of all the different stages that our code goes through. We want to be able to know who does what and why they did it and when they did it. It's basically something to help us keep accountability and know who did what. This is especially really important when you're working in larger organizations or larger groups, where you necessarily won't be working at the same time, and you're going to have to delegate tasks. So when we talk about version control, we talk about it in two ways. We can talk about a centralized version control system or a distributed version control system. So a centralized version control system, which is this image right here on the bottom right, it's essential we have one server which has the repository. The repository is your code base. It's what keeps a history of the code. It's what keeps everything. And so then you can have multiple different PCs or people accessing that code base consistently, pulling updates from it or pushing updates to it. So that's a centralized version control system. A distributed version control system is a little bit different in the sense that instead of consistently talking to a server, we make a copy of the repository on our local machine. And then with that local copy, we can go ahead and push an update to it locally. And then once we're done with our code, we can go ahead and send it back to the server. This is way handier because this saves a lot of downtime since we don't have to consistently communicate with the server. So this is what Git ends up being. Git is a distributed version control system. So any questions so far about this version control concept? Also feel free to put questions on the chat. All right, I don't see any questions, so I'll keep going. So alongside version control, another important concept that comes with version control systems is the concept of branching. So here's a little diagram of what that is. So in any repository, you can create a branch or a copy of that repository. Work can be performed on that branch, and eventually it can be merged back into the main copy or the main branch. So why are branches important? So branches let you test things that might break your main code. You know, let's say you want to add an extra feature to your code base that you're not entirely sure if you want to keep at the end. Branches let you go ahead and make a copy of that and work on it without having to really influence the main code, right? And so then if you like it, you can simply just merge it back into the main branch, or you can toss it. Git also provides this functionality. So when it comes to merging, version control systems should automate it, but sometimes merge conflicts occur. What a merge conflict is when the version control system is a little bit confused over what version of the code it should keep. Because sometimes maybe you're working on a file that's being also edited on the main branch. And so then when you go ahead and rejoin your file with the main branch, you might get some merge conflict. The version control system might not know which work to keep. And then it's up to you to fix that manually. That is a little bit out of our scope for this workshop, so we're not going to cover on how to fix merge conflicts, but you should know that they exist, and it's also really important for you to be aware of them because even though version control takes care of a lot of the communication for you, you still need to communicate with your teams clearly and know exactly what part of the code someone is working on. Any questions on branching so far? Feel free to come off mute as well. All right, I don't see any questions in the chat either.
Wait, I have a question.
Oh, what's up?
So like, what's a good like naming convention for branches? Is it usually like whatever the task is, or is it like just, I don't know, like the name of the person on the team or something?
It's really up to you. I'm personally not aware of any naming convention for branches. Sometimes I know people might name branches based on the version that they're working on. So let's say you're working on a version 1.0, you want to make a 1.1 branch. I know that's something that happens. It's really up to you.
Okay, cool. Thanks.
All right. All right. Good question. So now let's get into Git itself. So here's a brief introduction into what Git is. So Git, as I said earlier, is a distributed version control system. This means that it keeps a copy of your repository on the local machine. So Git also works as a series of snapshots. We can call these snapshots commit. A commit is basically an update that a user makes to the code base. So what's cool about this is that if you wanted to go back to the very first commit that you ever made, you can do that. I don't know why you would do it, but you can. So this allows a lot of flexibility in how you use Git. And so with Git, the files goes through different states in their life cycle. So let's say you're beginning to work on a Git repository. You copy a Git repository over. Every file is going to start off as unmodified, every file that exists already in that Git repository. If you make any change to the file or if you add any new file, then we're going to actually get started on the life cycle of a Git file. They're going to go under untracked. That basically means that Git knows that a change happened. Git can see something it doesn't recognize, but it doesn't keep track of it because you haven't told it to keep track of it yet. Once you're done modifying all the files or adding all the files that you want to add, then you stage the file. This basically lets Git know, hey, this is what I'm going to commit. This is what I want to add to the repository. Once you're happy with all the files that you have staged and you know what you actually want to commit to the repository, then you can commit it. And then all of your files go back to this unmodified state. And then if you modify it again or you add another file, you're just going to have to start the cycle all over again. Once you're happy with your commits and you've done everything that you want on your local repo, then you can push it to the remote repo and make it available for everyone else to see. Right? So that's a brief introduction to Git. Any questions on this slide or anything that we've covered thus far? All right, cool. You guys are getting this pretty fast. So now let's get you guys started on GitHub. So actually, just to make sure, please press yes on your participants button if you already have a GitHub account and Git installed on your computer. If you don't know where the yes button is located, you can go to your participants tab and it'll be right there. Right? I see most of you have it. So here, let me go ahead and copy this link into the chat. So you want to install Git, and you also want to make a GitHub account. So I'll give you a few seconds to go ahead and get that set up. Right. And then, yeah, just keep your yes symbols up. So once everything is set up, I can see. Then also let me know if you need any help getting GitHub set up. Any questions that anybody might have about GitHub or Git while we're waiting? All right. I'll give you guys a few moments. So I guess a follow-up question, actually. How many of you have actually used Git before? Just say it on the chat or say it out loud. Or give me a thumbs up or something.
I've used it before.
Cool, cool. Awesome. So, okay, I see a few of you have used it before. All right. Right. Does anybody need more time on installing Git and getting a GitHub account set up? If I hear no response, I'm just going to move forward with the demo. Nobody needs more time? All right, I'm hearing no response. Okay, let's dive right into the GitHub demo. So I'm going to go ahead and pull up my terminal right now. And so I will also give you guys this link right here because this link will be necessary for the Git demo. Let me pull up the chat. So this is the repository that you're going to be pulling from. So let me pull up my terminal. So we're here with your terminal open. So we're going to clone this repository onto your local machine. The command will simply be git clone, and then you should have a copy of your repo on the local machine. When I do ls, I can see it right here. So I'm going to go ahead and cd into this repo that I've created. Right, so now here we have this Git repo, which should have two files. It should have a readme.md and a sample.c. Right, so now we're going to talk about the lifecycle of the files. So first of all, let's see where the files are actually at right now. Right now, there should be all the files at unmodified. So when we type in git status, we can see everything that Git can see, right? So we can see that there's nothing to commit, working tree clean. That just means that Git can't see any changes. There aren't any changes in the repo yet. So let's go ahead and make a change. So I'm actually going to make a change by creating a new file. So I'm going to touch demo.py. For those of you who don't know, touch just creates a new file on your Unix shell. So now we can see demo.py. And so now when we type in git status, we can see that this file is untracked, right? So in order to let Git know that this file exists, we're going to go ahead and stage it. So to stage it, the command is git add and then the name of the file. So now when we do git status, we'll see that the file has been staged. It says it's a change to be committed. So we can actually go ahead and reset, right? We can unstage this file as well. So when we do git reset, it unstages it, and now it's back here. Another thing you can also do, let's say you want to make a massive commit, right? And you don't want to type in all of the file names. Let's say you have something like 20 files you want to add. You can just do git add dot. That basically adds everything in your current directory, right? So we have that. So now when we do git status, you'll see that file is there. And now we can commit it, right? So this is going to be updating our local repository. So when you commit, you're almost always going to have this little -m argument. This -m argument basically tells Git, hey, I'm going to put a comment. Git requires that every commit that you have comes with a comment, letting other developers what you just did. So my comment will be pretty simple. It'll be added a demo file, right? The comment has to be in between quotation marks to let it know that it's a string. And then the file has been added. When we do git status now, we see that we are ahead of our origin branch by one commit. That means that our local repo is ahead of the repo on the main server, which the repo on the main server, again, you can reach it using that link. So now I'm going to update the repository. You guys aren't going to do this because it won't let you do this. You don't have access to my repo. So what I'm going to do is I'm going to push this change, and then I want you guys to go ahead and pull this change, right? So I'm going to type in git push, which basically updates my main repo. And as soon as this finishes, you guys should be able to do a git pull on that. So go ahead and give the git pull a chance. And then once you do the git pull, just give me a yes on the yes button. Just letting me know that it works. If any of you guys have any troubles, let me know. So I'll give you guys a few moments for this. Let me clear all. So yeah, just give me the yes if you're able to successfully pull from the repo. Awesome, I see one yes. Are any of you struggling with this? Are the results not quite what they should be? All right. I don't see many yeses, but unless someone says something, I'm going to assume that everybody was able to successfully pull. right? If you weren't able to successfully pull, say something. Otherwise, I'm just gonna keep on moving with the demo. All right, I don't hear anything. Awesome. Okay, so we'll go ahead and keep going. Now, everybody should have this new updated repo with a demo file on it. So now I'm gonna teach you guys a little bit about branching. So in order to create a new branch based on the copy that you're on, you're going to use this command, git checkout -b. B is the thing that's gonna let you create this new branch. Then we're gonna name this branch whatever we want. I'm just gonna name it new branch for my purposes. Now we're going to be switched to a new branch. Now on this new branch, we can make changes to it, right? So the change I'm going to make is I'm going to add another sample file, right? I'm going to add a test.py, and then when we do git status, we see this we're in this branch, and then I want to go ahead and add this file to test.py, right? So now we see this. Now we can go ahead and commit this to this branch. Okay, now this belongs to this branch. So now when we go, let's go back to our main branch to see how that looks, right? When we do git checkout, main, we simply go back to the main branch. And then as you can see here, I did an ls, and now you can't see the file that I just created. That's because this file is on the other branch, right? It's on our test branch. So now I believe I named this branch. Sorry, I forgot what I named, new branch. Okay, awesome. So now we're going to merge the two branches together. And the command to do this is just git merge, and then we're going to call new branch, and then bam, we've merged it, and this new file, whoops, this new file is now in here. Test.py is now in here. So that's it for branching, right? Any questions on the concept of branching? Anybody had any trouble following along with that? Right? Don't see anything. I'll go ahead and move forward. So now we're going to get you guys started on creating your own repo. So now let's go ahead and go to GitHub. So on GitHub, so here's my GitHub page, right? You can see the people that I follow. You can follow different people's repos on GitHub. And now I'm going to create a new repo, right? So the process of creating a new repo through GitHub is pretty simple. So I can name this repository whatever I want. So I'm going to name this Git Workshop New, right? And so I can make this public or private, which private simply means you get to pick who gets to see it. Public, anybody can see it. And then we're going to create the repo. So now GitHub gives you, it's super intuitive, super user-friendly. It gives you a few different options on how to initialize this repository. So if you have an existing repository that you want to use, you can do this. I'm not going to do that. I'm just going to create a new repository. So here it gives you a bunch of commands that will help you create this repository. So you can just copy the commands, and you can go ahead and do this. So let me break down what the commands actually did. This command creates this string and puts it into a new file, readme.md. This command initializes the directory that you're in into a GitHub repo. This command adds the readme.md for GitHub to track it, for Git to track it. This creates the commit. Then this switches our branch to main. Then here we can go ahead and link our repository to the remote repository, and then we just push, and that's it. So now when we refresh this, we are in this brand new GitHub repo that we just created. And now we can directly go ahead and commit to this repo, right? So you can follow the same Git workflow that I was doing earlier. It's pretty simple stuff, but yeah, so that's the general workflow for Git and GitHub. So now we finished the demo. Are there any questions? Feel free to come off mute if you have any questions, or private message me. Right, I'll give you guys a few moments. All right, I don't see anything. All right, well, that's it for the demo. Here are a couple of additional resources. I will be uploading my slides and these links into the workshops channel. And so you can always feel free to reach out to me if you have any questions about Git, or if you want to do certain specific things in Git. I'm always available. And then other than that, I'll open up the floor for questions if you guys have any. Then I'll go ahead and stop sharing and stop the recording.